do this. Engine Room Principles Test 5 from Volume 2, Chapter 5. Now you guys have already done some of this stuff that we're talking about, so you shouldn't really be all that lost. The flatness of the cylinder head deck is checked by using a depth gauge and a micrometer. Is that true or false? How do you check the flatness of the cylinder head deck?
Filler gauge.
And what else?
Edge.
And a straight edge. Straight edge and a filler gauge. Special straight edge and a filler gauge. Calibrated straight edge. It's got to be just right. And you actually buy those. I've actually got a long one right up there that's for them big long 6-cylinder heads too. Measurements of engine components are made in metric units or USC.
So one was false?
That would be actually true. Yeah, the first one was false. Dye penetrant inspection can be used on non-magnetic material as well as on magnetic material. Is that true?
I don't know what penetrant.
That is actually true. Dye penetrant. Well, dye penetrant inspection is you're looking for cracks. That's what you're trying to do. And whenever you spray it, this stuff on there, and you just spray the activator, it basically makes the cracks light up. It's basically looking at that kind of thing. The cylinder head deck must be cleaned with an abrasive pad on a drill or grinder to remove corrosion or rust. Well, we typically like to use not abrasive pad, but we use bristle discs, and so that one there would be false on that one there. But a lot of people, if it's a cast iron cylinder head, they'll use some kind of an abrasive pad, and you just.
One we were doing it on made out of aluminum.
We were doing that with a white bristle disc.
I mean, the
and
actual cylinder head we were doing was that.
That's cast iron.
Okay.
Yeah, but we were using a white aluminum. White aluminum disc the white disc you're supposed to use for aluminum. The green disc you're supposed to use for cast iron. But we use the white ones on just about everything. Now those bristle discs cost $13 a piece. They're not cheap.
Lord.
So if you got to just get a new bristle disc, they're $13. And that little thing, if you got to be careful how fast you spin it, because it spins about 20,000 RPM, and those little bristles can come off of there and go whirling away somewhere. And your buddy may be over there looking the other way, and about the time he looks here comes a bristle. So that's why safety glasses in the shop are a good idea, right? A telescoping gauge is most often used where a dial bore gauge will not fit. That is true. I've got a dial bore gauge. I've got to show you guys how to use that on that engine block that they've got torn apart out there right now.
Is that what we were doing?
There's some people standing out there.
Huh?
There's some people standing out
So
there.
dude looking for
Okay.
the car.
Let me get him in here. Tell him to come here. Hey, man.
Hey,
Yeah.
y'all gotta keep overnight again?
Yeah, we probably should. We're looking at the. He's actually got the spark plugs out of it, and we're in the middle of our diagnosis on it. So if you could leave it with us another night, that would work.
Another run?
Yeah, leave it one more night. We'll see what we can do. Okay, that work? Okay. All right. Is he the only one out there, or somebody else? I guess they were just out there talking to him, or what? Okay.
And he was talking to somebody else, probably from Wyoming. Two people just walked off.
Yeah, there you go. A straight edge should be handled with care and used only for checking distortion.
I'd say.
You're not going to use it for a pry bar. You're not going to hit anything with it. You're only going to use it to check for distortion. Right? That's true, right? Plastic gauge can be used to determine the clearance between the crankshaft bearing and journal. Plastic gauge, this little waxy string that the green is the right size for that. You put a little piece of waxy string on there, and I guess I'm show you guys how to do this. You tighten it down, tighten your bearings down, take them back apart, and however flat it squished that flat waxy string out, you got a little gauge on the side of the paper, and you can tell how much clearance you got. That way, it's the most accurate way to do it. And the plastic gauge is a little paper sleeve with the waxy string in it about that long, and it costs about $2. Real cheap and easy to use, huh?
And it's true.
Yeah, it's absolutely true. That's the best way to do it. No more than 1.5 thousandths. One time I had an engine, and I never really understood why people kept bringing oddball makes of cars to the Ford dealership, but I had a Chevy Citation in there that I put a crankshaft kit in it, which is basically a crankshaft kit comes with bearings and a crankshaft and a machine to match and all this kind of stuff. So I had to put a crankshaft in that car and did it with the engine in the car. It was tricky. Had to pull the transmission out, and pull the pan off, and all this kind of thing. And so I put the
Took the front end off of it, didn't you?
no, it was actually just drop the pan. And that particular one wasn't all that difficult to do, as I remember. But one way or another, I got the crankshaft out and I put all the bearings back up in there, and I put it back together. And when I cranked it up, it had a rumble, a bearing noise in it. So we pulled the pan back off and plastic gauged the bearings. In order to do it with the crankshaft in the car, you have to put something like a business card or something underneath a couple of the bearings on either side, so it'll push the crankshaft up, because the weight of it is going to make your reading wrong. See what I'm saying? And so anyway, we checked it and it was like 2/1000ths clearance, which was too much. And so we pull the crankshaft out, and remember these were supposed to fit. Pull the crankshaft out, send it to the machine shop. They machined it down another 10,000. No, they machined it 9/1000ths and gave us 20/1000ths undersized bearings, which was hoped would take care of that, but it still had too much clearance. And so finally we just filed the main caps a little bit to tighten it up, and we left it out of there like that. That was just one of those things that just wouldn't let go of us. You kept fighting with it, and I worked on that thing for about 4 or 5 days. Finally got it out of there. But
How long was that job supposed to pay?
I don't even remember. It was a long time ago. I mean, I think changing the crankshaft out of that didn't pay all that well. But I was working on it in and amongst other jobs too, because when stuff's flowing thick and fast. There was a time that when I was working over there that I was the only one. I was a line mechanic then, but I was the only one doing drivability work, and I'd have to work out 12 or 15 cars a day. And they had a rack that said drivability problems, and I was the only one doing them. And I had to get rid of black smoke and skipping and bad running and electrical problems and all that kind of stuff. I didn't have time to sell stuff. I just had to crank the thing through it. I've had one that started giving me a trouble. I would shove that one to the side, and I'd work out 4 or 5 more, because it's better to have one customer that's a little disappointed than 4 or 5. You know what I mean? Somebody like a bank teller doesn't have that ability. They got to finish the customers in order. But I could actually, and don't be surprised if you're irritated at having to stop on one job and start on another one. If you're in a busy shop, you may be really into what you're doing and moving toward finish. They may say, we need you to stop on that one, work on this one because it's more pressing right now. Or they'll take one in that's got a customer waiting or something like that. And so here you wind up having to, shift back and forth. But the smart guy is going to work smart and have 3 or 4 cars going at once anyway if he can. And it works really well at the end of the week when you got all that labor time turned. And sometimes it gets pretty busy out there. Let me see. Careful inspection and measuring of engine components are more likely to be done by a repair technician than an automotive shop. Ding, 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 ding. Automotive machine shop. What do you think? That's actually false. The automotive machine shop is going to measure that thing and look at it in ways that a regular mechanic won't. Regular micrometers allow the user to read the measurement directly, while digital micrometers require the user to calculate the measurement. That's false. You have to calculate the measurement when you've got a regular micrometer. Excessive crankshaft runout may indicate a bent crankshaft. What do you think about that? True. You remember that little story I told you about the crankshaft that broke on the 4.3 liter, or I mean the 4.2 liter that we had in this Ford pickup? And it actually, I get so confused on those 4.3. No, 4.3 is a Chevrolet.
Yeah.
4.2 is the Ford. But and those are 4.2 in the Trailblazer too, right? But anyway, this thing was, I get those little numbers on the end fouled up sometimes. But this is both a V6. Well, anyway, the crankshaft broke. I mean, we actually put a crankshaft in it because it was losing oil pressure, and I'll put an oil pump and cam bearing and all that stuff. And it went about 4,000 miles, and the crankshaft just popped right in the middle. I got a picture of it up there somewhere. And then we got another crankshaft kit because the guy, the parts man got us another crankshaft parts department. And when we put it in there and we torqued it down, it wouldn't turn. Now think about this catastrophic failure. You're driving down the road and the crankshaft just pops.
Something stopped it.
Yeah, and not when something stopped it, it broke. And when it broke, there was so much going on that it actually distorted the engine block just enough to where when we put the new crankshaft back in there and we torqued the rods, the main bearings down, it was locked up. It wouldn't turn. Well, that's not acceptable. You're not going to be able to do that. What would you do about that? What would you do about that? You got a distorted block because the crankshaft broke. How are you going to fix that? It's got to be fixed. You don't just put another engine in it. You're already this far into it.
You take it to a machine shop,
That's a good plan. What do they do?
machine it down to spec.
Well, yeah, he's right, sort of, but they're using the wrong language. Line bore. They basically, cut the, they actually cut the main caps down a little bit, and then they line bore it out to the original specs, and then you use standard bearings going back in there. Once they did that, and we put the crankshaft in there, and we tightened it down, you could just spin it with one hand. It's just beautiful the way it did. And that guy's still driving that truck. That was 7 or 8 years ago, and he's still driving it. Okay, let me see. I will tell you another little story about a crankshaft. I was responsible for maintaining this fleet when I was working in Southeast Texas. There was a Dodge, 78 Dodge crew cab that had a 318 in it, which is 5.2. and they noticed that the oil pressure was a little bit low, but it was running okay. And I didn't know if the gauge was lying or what it was, and the truck was a work truck and we had a lot going on. So I put an oil pressure gauge on it so I could actually read the oil pressure, and it was running about, you know, pretty well within what it, 10 pounds per 1,000 RPM is the minimum that you should expect. And it was running pretty well within those parameters, and so I said, well, let's drive it and see what it does. Well, what I didn't know was, and you didn't have any way of telling, the crankshaft was cracked. And the crankshaft, because it was cracked, was letting oil pressure leak out, pass through the crack, and that's where the pressure was going. And they were driving down the road about 60 or 70 miles an hour, and the crankshaft broke on that one, and it was one of those catastrophic failures, and so I had to put an engine in that one. But I says, can I put a 360 back in here? Because it's the same size and everything. He goes, oh yeah, you can just drop it right in there. Well, the oil pan wouldn't fit, but everything else was just fine. I popped a 350, 360 in it.
At the house.
Yeah, and that one, that's why I put a 360.
The number, like you said,
It's a 5.2. That's a 5.8. No, yeah, 5.8. That's what that is. So anyway, a metric micrometer reads in millimeters. The marks below the revolution line are in increments of what?
0.05.
A half a millimeter. That's right. Pressure testing, dye penetrant inspection, and magnetic particle inspection are several ways to check for what?
Cracks.
Yeah, cracks. Basically, you sprinkle those iron filings on there, and then you magnetize the cylinder head. The crack's going to show up. Those iron filings are going to stand. Pretty handy stuff. The camshaft bearing. Oh, here's something. You know how you check for a cracked piston? Like where you guys are doing, you're taking it apart. You want to see if the pistons are cracked because you won't always spot it. How'd you do that? You get something and you tap it. Because when you hit one that's cracked, it'll go thump. It won't sound the same. It won't go now tink, tink, tink. It'll hit a cracked piston.
What is that piston for?
This piston here, I think it goes in a 302 Ford. I'm not sure. Now, when I first came here, I came in behind a couple of other instructors that had been here before me. One of them had bought a bunch of parts to rebuild somebody's engine, and for some reason that deal fell through. I don't know what it was. And they had these pistons in a box up in the office. And then they called me one day and they said, we've got some transmission parts up here in the office that you need to have. And I says, okay. And they had come from down here originally. And I said, okay. So I went up there, and these weren't transmission parts. They were pistons, but the women in the office didn't have a clue what they were and all that. And so I'm going to show you guys, about these rings, how to put the rings on and take them off and all that kind of thing. So you can pull one off just like that and put it back on. And also, pay attention to the top ring, second ring, the oil scraper. These rings right here are a little bigger than the ones you guys are working with on that little PT Cruiser engine out there. And I was telling Adam earlier that these older engines had thick, high-tension piston rings on it, and it made the pistons wear the engine out more. So now they put low-tension piston rings for help with fuel economy. Here's something I want to say while I'm thinking about this. You see the ends of these rings, how they got a gap in them? Mm-hmm. Don't stack those. You want to put them on opposite sides of the piston. If you ever stack any like that, you'll have a compression leak right there by those wings. And whenever you pull it, you can pull them apart and see if them things are stacked like that, there's going to be a problem. So you actually need to turn them sideways.
And they don't move while the piston's going up and down?
Huh?
They don't really move at all while the piston's going up and down?
No, they stay right where you put them. Yeah, they're never going to go anywhere. That piston there is brand new, and it's never been in anything. But I use it for a perk. I use it to hold up. The people that watch these videos have seen me hold this same piston up 715,214 times. But I got some more pistons in a box over there. But when we started pulling pistons off, rings off, and putting them back on, for some strange reason, people are sort of clumsy and they'll break the piston rings and this kind of thing and all that. But every now and then I have to get another pair of rings. But I knew one guy was in a hurry putting an engine back together, and he put a piston in there with no rings on it. That was brilliant. It's an easy mistake to make. It's like jumping out of an airplane without a parachute, only it's not quite as devastating as how it turns out. Let me see. The camshaft bearings, valve lifters, push rods, rocker arms, and rocker shafts are all components of the valve train. Give that man a cigar. All right. The engine block must be inspected for all of the following except what?
Duct tape.
What part of that is not part of the engine block? The flywheel flange and pilot hole condition, what's that part of?
Transmission?
No, well, you're thinking in the right direction. It's a crankshaft. That's part of the crankshaft. A measuring instrument used to measure a cylinder bore, crankshaft main bores, or a large end of the connecting rod is the... Everybody like that answer? Dial bore gauge sounds good to me. Okay, now, everybody, do you guys got these vocabulary match things?
Yeah.
What's used to measure the inside or outside linear dimensions?
Dial bore gauge?
Micrometer.
What's that?
A measuring instrument that uses a spring-loaded plunger and swing needle gauge to display the measured value.
Dial indicator.
Dial indicator. Except, if you've got this dial indicator right here, this dial indicator happens to be digital. Now, if you're measuring lateral runout or something on a rotor, and you got it mounted on there and you're turning it through, you need to see a needle sweep, and you don't need to see this. You can understand how useless that would be, these little digital numbers going up and down. If you're actually measuring something like backlash on a rear end, this would work just fine. Donk. And then you zero it, and then you go donk, and it reads both ways, see? But every now and then you got to put batteries in this too, which is sort of a drag. You know. But anyway, I put some, the batteries are dead in this when I first came here. It was laying up here. I usually wave it around whenever I get a chance. Okay, measuring instrument used to measure the diameter of a large hole.
Is that a torque? Is that a
Dial bore gauge. I'm going to show you guys a dial bore gauge. Anybody use a dial bore gauge before? All right, you like that? What do you do with them? You can show us how to use the one that I got out here, huh?
What was the thing that we used to measure the, was it the hubs on that neon?
That's a dial indicator.
Oh,
Yeah. All right, so let me see the, hold on a minute.
19.
19, a measuring instrument with a fixed jaw and sliding jaw used for measuring inside and outside diameter and depth.
Depth gauge.
No. Caliper. Caliper. A measuring tool that expands to the inside diameter of a round opening. Telescoping gauge. You've used that. Some of you guys have used that already. A measuring tool used to measure the inside diameter of a small opening such as a valve guide.
Small.
Small hole gauge. That's not too hard to figure out, is it? Frequently called a thickness gauge.
Feeler gauge?
He was swift. The measuring instrument that allows holes and grooves of various depths to be measured.
Depth gauge?
Everybody like that answer? Sounds good to me. Let's do it. A measuring tool available in all three types: dial indicator, micrometer, ratcheting, and deflecting beam. Torque wrench.
Then obviously the last one is a torque angle gauge.
Well, we've got all three types of those here. Well, actually we don't. There is one that's got a round gauge on it that you actually, when you pull it, that needle goes around. It almost looks like a dial indicator. So when you pull it, it goes around to the torque.
My
you
dad's
pull.
got one of them.
Yeah.
And he's also got one that I like to use, the one that we hook up to the wheels most of the time.
Yep.
That's the one I prefer.
A measuring tool that indicates the number of degrees a bolt or nut has been turned.
Pete's cutter.
You used one the other day.
I know, I'm kidding. It's a torque angle gauge.
Torque angle gauge. Sounds good. All right, everybody happy with that? Now, let's go out here and look at our dial bore gauge.